Assalamu alaikum everyone. I'm Janati Maisha and today I'm going to present our research paper which is a study of contrastive learning methods for Bengali social analysis. And the authors of these papers with me are Farhana Hossein Shonali and Simon Islam Iftikhar, Sharkar Bulbul Ahmed and Faisal Muhammad Shah. And we are all from Department of Computer Science and Engineering of Ahsanul University of Science and Technology. So here is the outline that we are going to discuss. So our mother tongue Bengali is a complex language. Social analysis can also say sentiment analysis is quite challenging. But in this online-based social era, correct sentiment analysis is very crucial, even for mental well-being of ones. So, we propose to integrate a new technique, a new loss, in this sentiment analysis task named contrastive learning, which is far better than traditional cross-entropy, and we conduct it for binary class classification. So now comes the question, what is this contrastive learning and why it is working better? Well, contrastive learning is a technique based on push-pull mechanism. Say, we are using labeled data of two different classes, and here are some example words. The technique works for the representations one by one. The one in current time step we can call anchor. So let us take Uttam as our anchor for this time step. The same class as the anchor Uttam is Sneho and Sundar. They are pulled together, and the different class from this anchor Uttam are Pagol and Biroktikor. They are pushed apart. So different class representation are pushed apart from each other and similar class representations are pulled together. As it is a technique integrated in loss function, similar classes has low loss and dissimilar classes has high loss. That's why we get a representation like it, where the classifier, the decision boundary can easily be drawn. Now, why it's better? Because we don't have to train the whole representation. We just can train the classifier to place it, and the placement of the representations can entirely be handled by this push-pull mechanism, the CL method, or we can say the contrastive learning. So here are our research objective. Yes, we are utilizing this supervised CL method in Bengali, and according to our knowledge, this is the first time someone utilizing it in Bengali, and of course our methods outperform cross-entropy based models. So let's quickly head to our methodology. We have implemented total 2 contrastive learning losses with different advantages. One is supervised contrastive loss, in short is CL, another is contrastive adversarial training, in short ICEEICT. Okay. Our first and very basic loss, supervised contrastive loss, we have used labeled data, supervised, right? Labeled data. If we aimed for unsupervised contrastive learning, with no labels, there can be false positive or false negative, and in that case, where the representation should get closer will be distant, and vice versa, which can lead to a disastrous situation. So we have used supervised contrastive loss and implemented this push-pull mechanism. Here is our model architecture for supervised contrastive learning. So we have used BART, Bangla-BART pre-trained model for this sentiment analysis task. Labeled data is fed to the Bangla-BART tokenizer, which gives us the tokenized representation also with special tokens like KCP and CLS, and that representation fed to Bangla-BART pre-trained model, which gives us the sequence input, we can say hidden state, and then the classification occur, and for this classification cross-entropy loss is used, and the same sequence output, we can say hidden state, then go for data augmentation. We have used dropout based data augmentation here. Dropout based data augmentation here. Well, it improves generalization and reduce overfitting. Traditional dropout mask out the neurons, we all know. Here we use the same concept for data augmentation, where we got the augment by masking out random features of input sequence during training. Okay, the diverse variation of input data we got from this, and here Zeta is our anchor and ZZ is our data augment. You can say dropout based data augment. And these two goals for the contrastive loss calculation. Here we used a subcon loss, a built-in function, and then these two loss added up and makes our final loss, and then the back propagation occur and so on. So for our second loss, we have updated our process, which is data augmentation process, and it proposed a new technique which is adversarial training, and use adversarial example instead of dropout based data augmentation to increase the capability of our model. So here is the model architecture. Here we make a copy of our pre-trained BART model, and with one of our or we can say with the copy we add a small number called perturbation R to generate a slightly different version of our representation. We call the representation adversarial examples. Okay. Then again, here the zeta is our anchor and zz is our adversarial example. These to go and calculate the contrastive loss, and for our main version as well as the perturb version, for both the classification occur, and we got the two cross entropy losses, and by adding these three losses we got our final loss for contrastive adversarial training. As we use the adversarial training, a slightly different version made by using perturbation R, we got much better result than SCL here. So we have in our research we have used two binary level dataset. As we can see here, some of our sample examples are given, and here denoting two types of sentiment in both. Our dataset one is Bengali hate speed, BHS, and Brokomari book review, in short RBR. So let's see some analysis. So we have conducted our research with two kind of batch sizes, and which is 16 and 32, three kind of learning rate, and three kind of epoch, and also two kind of Banglabird pre-trained model. One is Banglabird and another is Banglabird base. This is the Electra base actually, and this is the normal base Banglabird. We can say Sagar Circle we have used for this, and Buet NLP we have used for this. And we have got our base result for Buet NLP, or we can say Electra base Banglabird. So let's see from the graph. As we claim, both our model outperformed CE, yes, for both the dataset. So for BHS, both SCL and CAT outperformed C by 3%, and for RBR, SCL outperformed C by 2% and CAT outperformed C by 3%. And here we can see that CAT also outperformed SCL by 1%, as it actually works with adversarial example. And as we have further discussed earlier, that our Banglabird pre-trained model, Buet NLP, works better for both the cases. So yes, we reached to the end. Some challenges and limitations we have encountered while conducting this research, like we face difficulty while implementing Electra-based Banglabird for CL as performed of and also as the performance of CL rely on hyperparameters. So more computing power was needed for conducting this research for a larger number of batch size, epoch, and other hyperparameters. So in the near future, we aim to do investigation on multi-level dataset also, and we want to expand the dataset with wide range of Bengali textual meaning, and we also aim to create our own dataset for unexplored field, and also we want to explore more contrastive learning potential in this NLP field. Thank you so very much. That's all from me. Thank you so very much for listening.